In this video, we develop a network to show some differences between volume rendering and the MeVisLab Path Tracer. You will visualize the same scene using both 3D rendering techniques and learn some of the modules for path tracing. As a first step for comparison, we are creating a 3D scene with two spheres using the already known volume rendering. Add 3 WEM initialized modules for 1 cube and 2 icosphere to your workspace and connect each of them to ASO WEM renderer. Set instance name of the WEM initialized modules to Sphere 1, Sphere 2 and Cube. Set instance name of the ASO WEM renderer modules to Render Sphere 1, Render Sphere 2 and Render Cube. For Render Sphere 1, define a diffuse color yellow and set phase alpha to 0.5. The render cube remains as is and the render sphere 2 is defined as diffuse color red and phase alpha 0.5. Group your modules and name the group initialization. Use the output inspector for your ASO WEM renderer outputs and inspect the 3D rendering. You should have a yellow and a red sphere and a gray cube. Add 2 ASO group modules and ASO background to your network. Connect the modules as seen in the video. If you now inspect the output of the ASO group, you will see an orange sphere. You did not translate the locations of our 3 objects, they are all located at the same place in world coordinates. Open the WEM initialize panels of your 3D objects and define translations and scalings to see all of them. The result of the ASO group now shows 2 spheres on a rectangular cube. For the viewer, you now add ASO camera interaction, ASO depth peel renderer and ASO render area module to your network and connect them. You now have a 3D volume rendering of our 3 objects. In order to distinguish between the 2 viewers, you now add a label to the ASO render area describing that this is the volume rendering. Add ASO menu item, ASO border menu and ASO separator to your ASO render area. Define the label of the ASO menu item as volume rendering and set border alignment to top right and menu direction to horizontal for the ASO border menu. Finally, you should group all modules belonging to your volume rendering. For the path tracer, you can just reuse our 3D objects from volume rendering. This helps us to compare the rendering results. Path tracer modules fully integrate into MeVisLab Open Inventor, therefore the general principles and the necessary modules are not completely different. Add ASO group module to your workspace and connect it to your 3D objects from ASO WEM renderer. ASO background as in volume rendering network is not necessary, but you add ASO path tracer material and connect it to the ASO group. You can leave all settings as default for now. Add ASO path tracer area light, ASO path tracer mesh and ASO path tracer to ASO separator and connect the ASO path tracer mesh to your ASO group. This adds your 3D objects to a path tracer scene. Selecting the ASO separator output already shows a preview of the same scene rendered via path tracing. Add ASO camera interaction and ASO render area to your network and connect them as seen in the video. You can now use both ASO render area modules to visualize the differences side by side. You should also add the ASO menu item, ASO border menu and ASO separator to your ASO render area in order to have a label for path tracing inside the viewer. Define the label of the ASO menu item as path tracing and set border alignment to top right and menu direction to horizontal for the ASO border menu. Finally, group your path tracer modules to another group named path tracing. Finally, you want to have the same camera perspective in both viewers so that you can see the differences. Add ASO perspective camera module to your workspace and connect it to the volume rendering in the path tracer network. The path tracer network additionally needs ASO group. You have to toggle detect camera in both of your ASO camera interaction modules in order to synchronize the view for both ASO render area viewers. Path tracing provides a much more realistic way to visualize the behavior of light in a scene. It simulates the scattering and absorption of light within the volume. For further information, please have a look at www.mevislab.de.